Hello friends, my name is Rahul Rathor. Welcome to the first video of Google Cloud Spanner database. Let's see today's agenda. Today we are going to start with the need of a spanner. Then we are going to see what is a spanner, its key features and use cases. So let's get started. Google Cloud already provides many database services. For relational database, we have Cloud SQL, where we have fully managed MySQL, PostgreSQL and SQL Server database. We also have AlloyDB. For non-relational databases, we have Firestore and Bigtable. We also have specialized and analytical databases like BigQuery for data warehouse and Memory Store for in-memory databases like Redis and Memcached. Then what is the need of a new database spanner? Let's try to answer it using CAP theorem. Let's revise few keywords before we talk about the CAP theorem. First, consistency. All nodes see the same data at the same time. All the nodes read the last written update. Availability. Every request receives a response. It guarantees system responsiveness even during failures. Partition tolerance. Keeps the system running even when parts of the network can't talk to each other. This is applicable when we talk about distributed systems. Now CAP theorem says a distributed data system cannot simultaneously guarantee consistency, availability and partition tolerance. You can pick only two out of these three properties during a network partition. Now, given the partition tolerance, we can pick either consistency or availability. So for any distributed system or on cloud, partition tolerance is something which is given. We can't go away with it. Then as per this CAP theorem, we can either pick consistency or we can pick availability. You would have seen that non-relational databases are good in scaling compared to relational databases, as it becomes difficult to ensure consistency as we scale in distributed data system or a network. So the Cloud Spanner database is an effort to create a relational database with scaling capabilities of non-relational database. Now, what is Cloud Spanner? It is only enterprise grade, globally distributed and strongly consistent managed database service. So it means it is globally distributed, but it is also strongly consistent. It is built for the cloud to combine the benefits of relational database structure with non-relational horizontal scaling. And as we see, it's a fully managed service handled entirely by Google, which means no maintenance windows, virtually unlimited capacity and automatic replication. Now see what are the key features of Spanner. Scalability. Now the Spanner is provisioned on nodes, and each node can handle up to 4 TB of data. So you can see every node can handle a very large volume of data. It scales horizontally by adding more nodes. So as per the need, you can add more nodes and scale it. And you can add these nodes dynamically. So you can dynamically rescale your instance within minutes. But it is not always necessary that you need to add a node. If your requirement is for a lesser amount of data, then you can start with the 1/10 of a node. That is called granular sizing. So this granular sizing is available from 1/10 of a node. Talking about availability, 99.99% SLA for regional instances. So 4.9 for regional instances and 5.9 for multi-regional instances. It means it is almost always available. So we can say it is a distributed service that is always available. Talking about performance, 10,000 reads per node per second and 2000 reads per node per second. And as we have seen, we can scale horizontally by adding more and more nodes. Now, we see Spanner is a relational database. Like any other relational database, Spanner has some standard features. Databases contains tables with fields and data types. We can use indexes to optimize queries, and relationships can be used to enforce referential integrity. But there are some unique differences in Spanner compared to other relational databases. First, you can co-locate data using interleaved tables for better performance. Interleaved tables are a powerful schema design feature that allows you to consolidate related rows physically on a disk. So this is especially useful for parent-child relationships where child rows are tightly bound to a parent. When you define a child table as interleaved in a parent, Spanner stores the child rows in the same split as the parent rows. And this means that reads, writes, and joins involving both tables are faster because they avoid cross split or cross node communication. And what is a split? A split is nothing like, it's like slicing table into smaller chunks. Now this interleaving is ideal for hierarchical data like customers orders, blocks and comments, projects and tasks. Second difference is stored procedures, triggers and user defined functions are not supported. So we have seen that Spanner is designed for global scalability, high availability and strong consistency. Now to achieve these goals, it deliberately avoid certain RDBMS features that can introduce complexity or reduce predictability in distributed environments. So all these stored procedures, triggers and user defined functions, if we have in any other database, in Spanner these are taken care in the application layer. So stored procedures, triggers and user defined functions are taken care in the application layer. You should avoid using counters as primary keys to prevent hotspotting. Now what is hotspotting? Hotspot refers to a region of the database that receives disproportionately high traffic, leading to performance bottlenecks and resource contention. Now why counters cause hotspot in Spanner? Because Spanner partitions data into splits based on the lexicographic order of the primary key. So if your key is a monotonically increasing value, such as any counter like 1, 2, 3 or a timestamp, then all these new inserts will target the end of the key range, which maps to a single split. So all these records, insert records, it will go to one node only. All the write concentration will go on one node and it will increase latency and reduce throughput. And this defeats the very purpose of Spanner horizontal scalability, the very thing that it is built for. What we can use then in place of counters or primary keys? We can use UUIDs or some randomized strings as primary keys to spread inserts across the splits. Now we are going to see Spanner's distributed architecture. Spanner databases are replicated across multiple zones in a region and they can be replicated across regions for a high availability. It can scale horizontally by adding nodes to handle more data and traffic. And all the tables are physically divided into splits which are distributed across the nodes. We have already talked about splits. So far we have seen what is the need of Spanner. What is a Spanner? Its key features. Now we are going to see its use cases. We have seen the key features of Spanner. These are high availability, horizontal scalability and global consistency. So our use cases should be related to these features. Let's see for high availability. Here the use cases can be financial institutions, healthcare and online retailers. These are examples of industries needing the highest level of availability possible. Horizontal scalability. Here the use cases can be retailers on Black Friday or Big Billion Day sale, gaming companies releasing a new game. Now global consistency. Here the use cases can be global financial transactions platform. Let's explore it more. For example, a multinational fintech company operates a real-time payment gateway across continents. Say users in India, Europe and the US are transferring money, checking balances and reconciling accounts simultaneously. Now, global consistency ensures that every transaction reflects the latest state of the database, no matter where it originates. A user in London transferring funds to a recipient in Mumbai sees the same balance and transaction status as the backend system in California. It prevents double spending and reconciliation errors. So let's have a recap of what we have learned so far. We have seen why Spanner. Traditional databases struggle with global scale and consistency. Spanner was built to solve this, offering relational structure with horizontal scalability. We also saw what is Spanner. It's a fully managed, global distributed, strongly consistent database service by Google. It combines SQL features with NoSQL scalability, which is ideal for modern cloud native applications. We also saw the key features: global consistency with synchronous replication, high availability, 4 nines SLA for regional implementation and 5 9 SLA for multi-region. Horizontal scalability. It can scale to trillions of rows across zones and continents, and the performance can be 10K reads per second and 2K writes per second per node. For architecture highlights, we saw that data is split and distributed across nodes. Tables can be interleaved for performance. No triggers or stored procedures is supported. It is designed for scale, not legacy patterns. So triggers and stored procedures, they can be taken in the application layer. And we saw the use cases: financial systems needing global consistency, retail and gaming platforms handling traffic spikes, healthcare and e-commerce demanding near zero downtime. That wraps up today's session on Cloud Spanner. In the next video, we are going to create a Spanner instance using Cloud Console. Thanks for watching. Drop your questions or thoughts in the comment box. I would love to hear from you. Stay tuned for more such tutorials and hands-on.